Let's talk about power systems and synchronizing. In particular, I want to talk about synchronizing ATS systems with one mains and multiple generators. So under normal conditions, a site is powered by its main supply with the main circuit breaker closed and the master generator circuit breaker open. At the point at which the mains fails, the main circuit breaker is opened and the system start is given to the generators. So those generators then start up, get up to their speed and volts, and one is going to be faster than the others. This one closes its circuit breaker immediately. Those other two generators then have to synchronize to that first generator. If they were to close their breaker without synchronizing, the generators are going to crash parallel and there's going to be damage. Okay, so once them generators get into sync, they close their breaker, and then all three generators are operating in parallel. And basically, when them three generators are operating in parallel, we can close the master generator circuit breaker. The site load is now restored, the power's back on, but it's not from the mains, it's now from the generators. The generators then have to equally supply load to the site. You can't have one generator supplying all the load and the other two basically at no load. All three generators have to share the load equally. In practice, it's never perfect, you're always out by a few kilowatts or so, but in general they're pretty equal and the load is shared equally amongst them. Okay, so now the mains is healthy again. Now what we need to do is we wait for a period of time that mains is stable. We don't want to just go back to mains for it to fail again. We need to make sure it's stable and solid before we go back to mains. Okay, so when we're ready to go back, the generators need to synchronize back to that main supply. We have no control over the mains, so the mains can't synchronize to the generators have to synchronize to the mains. To synchronize, we need the phase angle correct, we need the voltage correct, and we need the frequency correct. Once we're in synchronism, then we can close the mains breaker, and the mains and generators are now in parallel. We then ramp down the load on the generators, which means the mains takes more load. Eventually, when we get to a low level, we open that master generator circuit breaker. The site's now back on mains, the generators go into a cool down and eventually stop.